Dear colleague, welcome to this course in targeting the GPI. The course is based on the self-study lectures to the right. We have one lecture from Laura Sif concerning the GPI itself, then targeting the GPI, and finally targeting the GPI advanced. After completing the lectures, continue with the target practice. The GPI is, according to my own opinion, the most difficult structure to target. It takes me considerably longer time than the other targets. The literature is filled with examples of misplaced electrodes that are presented as being in the sensory motor posteroventral GPI, but which are in reality in the anterior limbic GPI, the GPE, or even in the putamen. I target the GPI in 5 simple steps. First, I place the target according to the atlas coordinates. Then we modify the depth and laterality according to the optic tract. We choose an entry point, typically at or within 10 mm from the coronal suture at an angle as steep as possible. We then modify the laterality and anterior-posterior position according to the target as seen at the ACPC level in the horizontal plane by moving the target and entry point. Finally, we optimize the laterality and anterior-posterior position with consideration to all levels of the GPI as seen in the horizontal sections. Now let us go through these steps in detail. I use a proton density sequence which is fused with a T1. The ACPC is identified on the T1 and the proton density sequence is optimized for visualization of the GPI at the ACPC level. It should be possible to see the lamina between the GPI and the GPE and the border between the GPI and the internal capsule. We now start with placing the target according to atlas coordinates. The inter-individual variations are considerable regarding the GPI, but the atlas target is a good place to start at. We put the target initially at a laterality of 21 mm, 2 mm anterior of the mid-commissural point at a depth of 4 mm below the ACPC plane. In the second step, we'll modify the depth and laterality according to the optic tract. Here we see the close relationship between the optic tract and the GPI in the coronal target plane. And here we see it in several different projections. The optic tract is seen in brown and the GPI in blue. Now we move the target to the upper lateral corner of the optic tract on the coronal image. And here encircled in yellow is what I interpret as the optic tract. We then look also at the horizontal plane. And this is what I interpret as the lateral border of the optic tract in the horizontal plane. If the upper lateral corner of the optic tract is not within 2.5 to 5 mm below the ACPC plane, then it is likely that you are looking at the wrong structure and you should carefully analyze the images again. In the next step, we'll create a trajectory. We will normally choose an entry point within 10 mm from the coronal suture at an angle as steep as possible. Neither sulci or ventricles should be transected. The next step, optimizing the target at the ACPC level, is the most important one. I use this level since I find that the GPI is most often best delineated and has a large area. This is also fairly consistent between patients. The coordinates are of course not to be trusted, and if I find a large GPI with distinct borders and typical shape best delineated at 1 mm below the ACPC, I would of course use this level. However, not before having convinced myself that my eyes are not fooling me. The target should be placed in the posterior third of the GPI. I measure the GPI and define the posterior third. Then I will define the medial and lateral borders of the posterior third of the GPI. I will then adjust the coordinates in X and Y in order to optimize the position of the electrode. The red cross is what I consider to be the target point at this level. It is centered in the posterior third, but somewhat more anterolateral. However, depending on the other levels, one will often deem it necessary to make a compromise, and the yellow crosses marks points I consider to be satisfying. When compromising, it is better to be closer to the GPE than to the internal capsule, and the electrode should of course never encroach on the internal capsule. Before continuing, measure the distance from the posterior tip of the GPI to the anterior tip, and then to the chosen target in order to verify for yourself that your target is in the posterior third. Here we have a typical patient, 1 mm above and at ACPC level. Here the GPI is large and well delineated. In the second column, I put an atlas on the image, but I have adapted the size and location to create an impression of what shape the GPI might have. In the third column, I've delineated what borders I see in these images, well aware that these are not entirely correct, and also where I would put the target. When we optimize the target at the ACPC level, we move the target at the deepest level. Normally, a good position can be achieved at both levels without major problems. The changes at the target level are most pronounced in the anterior-posterior direction in most patients. Concerning changes in laterality, the relation to the lateral border of the optic tract is most interesting. A posterior shift of the target will often necessitate a compensatory change in the lateral direction and vice versa. I do not mind moving the target 1 mm more lateral, but I am reluctant to pass the border of the optic tract in the medial direction. Then, in the last step, we optimize the target and trajectory in accordance with all levels. As I said earlier, the most important thing is to place the electrode in a good position at the ACPC level. If you have done this, and if you also have placed the electrode in a good position in relation to the optic tract, then no further adjustments will probably be necessary. But you should, of course, always check the position of the electrode at all levels. Here we see the patient presented above with the implanted electrodes from 5 mm above the ACPC down to 4 mm below the ACPC plane. The left electrode has deviated slightly to the left, but an excellent clinical effect was achieved with low stimulation strength. So, when is an electrode misplaced? The evaluation is done at several levels, but the most important is the one where the GPI is clearly visible as above. If the electrode is not mostly within the yellow area, then I suggest you consider relocation. Concerning the depth, if you have one contact at the approximate level displayed above, more or less ACPC level, and at least one contact above and below, then I would not consider moving the electrode due to suboptimal depth location. In some patients, targeting the GPI will prove more difficult than in others for various reasons. We will now look at circumstances making the targeting difficult, common mistakes in targeting the GPI, and how this can be dealt with. Unfortunately, the targeting can be difficult due to many different circumstances, why it is not possible to provide one single solution. We will have instead to draw on a number of examples. we start with problems with visualization of the GPI. If it is impossible to perform an MRI, for example due to a cardiac pacemaker, then you can of course use atlas coordinates and a CT. However, remember that the variability of the target in the GPI is very large, why the procedure should be done with the patient awake to allow for intraoperative macrostimulation. See the lecture on pallidotomy for further details. If you always have problems with visualization of the GPI, then the first thing to do is probably not to study this lecture, but to improve your MRI images. Today it is not, or at least it should not be difficult to find sequences with a good visualization of the GPI and surrounding structures. The sequence we use is presented in preoperative stereotactic MRI. However, it is difficult to copy a sequence directly between different machines, even from the same manufacturer. Further, a good result can be achieved in different ways. We use a proton density sequence, but others have a good visualization of the GPI with a T1 or a T2 or inversion recovery. If you want to optimize the MRI sequences for the GPI, then one way of doing this is as follows. I suggest that you download case 4 and 5 into your navigation system, then arrange a meeting with your radiologist and with your MRI physicist. Show them the lecture targeting the GPI and explain what you need to see in order to target the GPI. Show them patient 4 and 5 in your navigation system as an example. When your radiologist and MRI physicist understand what you need to see and why, then it is easier for them to suggest an adequate MRI sequence. In order to safely identify the GPI, it is necessary to identify also the other parts of the lenticular nucleus. This is done at the ACPC level, where you will be able to identify the GPI, the lamina between the GPI and the GPE and the putamen. It's a good idea to take some time at the ACPC level to define the different structures. Before identifying the target, answer the following questions. What is GPI? What is the medial border of the GPI towards the internal capsule? What is the lateral border of the GPI? Is there a visible lamina between the GPI and the GPE? What is GPE? What is putamen? Is there a visible inner lamina in the GPI dividing it into two parts? Where is the posterior tail of the GPI bordering on the lamina GPE? What is the posterior third of the GPI? The GPI is sometimes visibly divided by an accessory lamina, lamina pallidi incompleta. Above is an extreme example at the ACPC level. Normally this is when appearing more discrete, especially at the ACPC level or above. People have been fooled by this accessory lamina to identify the GPI pars medialis as the GPI and the GPI pars lateralis as the GPE, but this can easily be avoided by identifying all parts of the lenticular nucleus. Here we see the border between the GPE and the putamen, the lamina between the GPI and the GPE, and finally the inner lamina. We can now identify the GPE, the external GPE, and the internal GPI. Sometimes it's difficult to visualize the lateral border and the posterior tail of the GPI, and this is probably the most common problem when targeting the GPI. Here we see the target area at the ACPC level and two possible ways of incorrect delineation of the GPI with the target point ending up in the GPE. And finally, a correct delineation of the GPI. These mistakes could easily have been avoided by simply recounting the main parts of the lenticular nucleus, since in these two examples the supposed GPI is in its posterior part bordering directly on the putamen without any GP or lamina between, which of course is impossible. Unfortunately, counting is not enough. The image often consists of many lines and areas that can be connected or separated in many different ways. Hence, we need to interpret what we see and choose the most likely interpretation. A good rule of thumb is that if it looks like the GPI, then it is probably the GPI. The different parts should look similar to the atlas, and most often their relative size should be similar. We should look at different levels. A visible line or border that appears only at one level is probably of no interest. Real borders will be consistent over several levels. The same is true regarding different projections. Look at the coronal images and try to identify the different parts of the lenticular nucleus. Look then if the lines are consistent in different projections. Above you see how you can identify the lamina between the GPI and the GPE in the axial plane, the coronal plane, and in probe's eye view. We then come to the lamina pallidi medialis. The lamina between the GPI and the GPE is sometimes seen only as a thin border line between the GPI and the GPE. In other patients, it will be quite wide. Often it is probably included in what we have delineated as the GPE, and sometimes in what we have called the GPI. This will, however, not have a major effect on the targeting as long as we are able to correctly identify the posterior tip of the GPI, as will be discussed further below. A common problem responsible for many misplaced electrodes is difficulties in correctly identifying the posterior tail of the GPI. Often the supposed tail is extended to include part of the lamina and the GPE, which will affect the targeting. The opposite is also sometimes seen. Sometimes people will cut the tail of the GPI. They will misinterpret what they see and remove the posterior tail of the GPI, hence placing the target too anterior. Here we have one example of incorrect identification of the lateral border and posterior tip of the GPI in red. And here we see in yellow the correct delineation. This is also very similar to the atlas. These mistakes can be avoided by looking at more than one level and at more than one projection. Further, remember that the GPI of the patient should look at least similar to the GPI of the atlas. If you remove the posterior tail, it will have a different shape and be too small. A more common problem is extending the tail of the GPI. The posterior medial border of the GPE, with or without visible lamina, is much longer than what many would estimate intuitively. It is much wider here than in its center. Further, the posterior medial border of the GPE is similar in length to the posterior medial border of the putamen. The posterior medial part of the GPE is expanding and looking somewhat like a mermaid's tail. The mermaid's tail is to a larger or smaller part made up also by the lamina. In the example above, the target, the red dot, was suggested to posterior since the patient had a very wide lamina, and this was mistakenly identified as a part of the GPI. The lamina is, however, visible in the first image and is clearly seen in the second image where another sequence was used. Concerning difficulties in visualizing the medial border of the GPI, then we have never found it difficult to identify this. But some groups are using sequences where this might be a problem in some patients. If this occurs, the safest conduct is simply to place the target close to the lateral border of the GPI and often slightly more anterior. In this manner, one reduces the risk of ending up in the internal capsule. Sometimes it is difficult to see the optic tract on the coronal images when you are starting looking for it at the atlas coordinates. Simply move 1 to 2 mm in the anterior or posterior direction and you will most often find it easily. Remember also to visualize the optic tract at both the coronal and horizontal images. If you are not experienced, it is possible to mistake some other structure for the optic tract if you look only at the coronal image. But if you look simultaneously at the horizontal image, this should not be a problem. If you are in doubt, you can always follow the optic tract all the way from the chiasm even around to the other side. This is easiest done on the horizontal images and in probe's eye view. Remember that you will have to adjust also the depth when following the optic tract. If you find that it is impossible to identify the optic tract, then you will have to ignore it. Then identify the target point at the ACPC level as described in the previous lecture, and then just extend the trajectory 4 mm further down. This will most often result in an acceptable electrode location. We then come to other problems than visualization. We start with narrow GPI. Some patients, especially those with secondary dystonia, have an atropic narrow GPI. In these cases, the marginal towards the internal capsule is small, while it is often a good idea to aim for a point close to or even at the lamina pallidi medialis. Since the GPI is more narrow in its posterior part, I will often target a point 1 to 2 mm more anterior than normal in such patients. In the example seen here, the GPI is 2.5 mm wide at the level of the electrode. We aimed at the point close to the lamina, and the electrode ended up somewhat more posterior medial, but in a good position within the GPI. Had we aimed at the center, then we would have ended up in the internal capsule with a poor result. Remember also to check the target area in detail before surgery. In some patients with secondary dystonia, the target area is completely missing, and hence GPI DBS is not possible, at least not on the side where the GPI is missing. Another target might of course be indicated. Concerning Virchow-Robin spaces, these can be abundant, especially in the putamen, and they are best seen on the T2 MRI. In the GPI, we have never found it necessary to change the target due to Virchow-Robin spaces. Regarding calcifications in the GPI, in a few patients, mainly but not only with Down syndrome and PCAN, there are significant calcifications in the GPI. These are often seen as discrete changes on the MRI, but you need a CT to visualize them properly. The calcifications are normally most pronounced in the anterior part of the GPI. Hence, the target area in the GPI will most often be accessible, but you might need to adapt the target or trajectory to avoid the calcifications. Thus, use a CT merged with your MRI for calculation of target and trajectory in these patients. There are some exercises in this course. I suggest that you download the operation plan for patients 4, 5 and 13 to 15 into your navigation system. Download also the corresponding case guides. Then create target and trajectory for the GPI bilaterally in all patients. After each patient, when you have finished, compare these with the suggested targets and trajectories. And with this, I will end this presentation, and I thank you for your attention.